You do have office hours, right?
I don't have office hours, but I'm around, and you can always just ask me, and I'm like, come on by, come on by. Okay, so I'm pleased with how the test went. So good job. Got it. There's always, some people who are kind of, that didn't go as well as I had hoped. That's okay. That's okay. As long as your final exam is better, well, you can keep your.
Oh, really?
Yeah. Thank you. I'll shift the weight of one of your tests to the final exam, right? So as long as you're improving, that's my goal. Surprise, surprise, surprise. So as long as you're improving, that makes me happy. And but now you've been in a test scenario and you've had these questions come at you. So now I think you can revisit the practice test and then the test and just kind of rest assured that they will always be kind of that similar. Okay? Obviously not the same, but that's why I give you a practice.
Is there a next test just based off of the newer material we're doing?
Yeah, so test 2, which is what I wanted to talk about here. I don't have a pointer, so test 2, I plopped it on November 21st, unless you guys are bogged down with other things. Then don't know yet. Well, then I'm first, so I win. Everyone else has to move. And it'll just be on chapters 3 and 4. So chapter 3 is what we started, I guess, last week, 2 weeks ago. We started, and then we've been working through polynomials, quadratics last day. Oh, and I found out it was a school-wide network outage, and it sounds like the problem is that I hook up to the internet like this, so that my iPad was like, there's no internet here, I guess, because Salto was down, everything was down, I guess, and projectors were down. So I got to my next class, and my friend Joya, she's wiping off the board because she had also had to do her lesson on the board. It was just a bad day yesterday, or last day. And what else did I do up here? Oh, in terms of the notes that I posted, I did post 3.7. Now we're not probably going to get to 3.7 today, but we're going to skip 3.3, and then we're going to skip 3.5 and 3.6. So they're not, missing. They're just, we're not going to do them. So, and then that's the end of chapter 3. So, what else? One last thing. I posted the bonus assignment for section 3.3. You have all the skills that you need in order to answer these questions. So that's why I thought, oh, let's give it a go. And you can always, read the section, or I'm sure there's a video somewhere, but I don't know where it is. I also posted the solutions to the test. So with kind of explanations. So you can kind of go through your own test in private, which is always nice. And then I do want you to come see me if you want to work through some of those problems. Okay? And like I was saying earlier, I don't have office hours because then I just am tied to my office and no one shows up in that time. And so I'm just available anytime as long as you kind of let me know. Usually I'm on campus and you can just come by anytime. I always say if I'm in my office, it's my office hours. So you can always just pop by. now's the time to remind you. I'm in the same office as Frank. So, you know, Frank's office, you know, my office, it's C104, just down the hall. Okay. Good. Good. I think that's good. Oh yeah, just to explain. There's a lot of things from last day. So here's the video from last year for 3.2. There was the first problem where we maximized the area for that fenced in area that is not included in here. You can go back into last year's playlist, but it's okay. And then here's the notes to match this video. And then here's our board scans from our class. Very confusing. But that's how they turned out. What a mess. But you were there. All right. So lots of things. Better be working. So like I said, test number 2 is on November 21st. Can't remember, was that a Monday or it's on the Thursday. Thursday, November 21st. We will do material on the Tuesday, but I'm not going to test you on it. And so, or if I do, it'll be very itty bitty and I'll tell you explicitly what to expect. Okay. Where's my pointer? Like I said, 3.3 graphs of polynomial functions. So now not just quadratic functions, but polynomial functions, things like the horizontal intercepts where the function equals 0, the vertical intercepts where x equals 0. Those are all things that you know, right? And so I thought that might be a nice bonus assignment. But because I don't care too much about graphing, I cut it. And I know you're thinking, wow, from the amount of graphing that we do, sure seems like you care about graphing. Well, I do, but now for a little bit of review here. All we really need today, well, not today, but in the future, is the quadratic formula, which will, of course, be on your formula sheet, but x is negative b plus minus the square root of b squared minus 4ac, or you can just memorize it, divide by 2a. You don't have to memorize it, but what does this do? Finds the values of x that make the function 0. Finds the values of x that make f of x equal to ax squared plus bx plus c equal to 0. Right, a quadratic function. Whoa, hello. Oh, that's scary. Is that on purpose or no? I'm just gonna mute. There. Whew. Little thrill. Okay. Okay. So, we're not going to use the quadratic formula today, but we will use it in 3.7. So what are we going to do today? Section 3.4 is the factor theorem and the remainder theorem, but they are all linked to polynomial long division or polynomial division. And so if we have a polynomial, something like maybe x to the 3 plus 4x squared minus 5x minus 14, this is no longer a quadratic, right? This is a polynomial because I have degree 3. Okay? And so if we know that x equals 2 is an intercept of this thing, just consider that scenario, then what could we do? We could factor this, right? Or we could divide out x minus 2 from this polynomial to find out what the rest is. Okay? And so kind of a funny story. So I did do my undergrad in math, of course, not of course, but my master's is in stats and then my undergrad is in math. But I also, so we moved back and forth between Sweden and Canada a couple of times. And so I did half a grade 1 in Sweden, and then I went straight into grade 3 in Canada because the years to stay with the same age group. And then I did grade 3 and 4 here, and then we moved back, and then I did grade 4 again, and grade 5, and then we moved back. So I skipped grade 6 and went straight into grade 7. So kind of choppy. And somewhere along the way, I didn't ever have to learn long division. Never. I never had to. I have a degree in math, and I never had to learn long division until I had to teach it. So it's not, super important. I do think polynomial long division is more important probably than actual long division. So I do not have a good handle on my long division, but I do have a good handle on my polynomial long division. Okay, so we're going to do this division, and I'm going to talk you through each of the steps, okay, as we go. So kind of show you by example. Now, first things first, you're going to want to give yourself a line because you have to write what the result is on the top line. Okay, and so then we'll do something like this. Write your division. Here we go, gearing up. So if I want to divide out x minus 2 from this thing, let's start with x minus 2. And inside, I'm going to have x to the 3 plus 4x squared minus 5x minus 14. So like I said, you'll need a line here to write your result. Okay. So first thing you want to make sure is that you have each of these x's. So all the powers of x starting from your highest degree. So x to the 3, x to the 2, x to the 1, x to the 0. Right? And so here, 1 and x to the 0, but anything to the power of 0 is just 1, right? So 14 times 1 is 14. So it's technically there. So step 1 is ensure all powers of x are written out. Good. Now, the next thing you want to do is we're going to work with this term, this x term here, and then the minus 2 is just along for the ride. Okay. So what we're going to do is we're going to take this x and divide it into x to the 3 and put the results up above here. Okay. And so I'll use pink because it's our first one. And I'm going to say 2 x to the 3 divided by x is x squared. Okay. which means that it's going to go up here. Because x to the 3 divided by x to the 1, you cancel one of the x's. I'll show why. I'm realizing now this is the same as x to the 3 times x to the negative 1, which is x to the 3 plus negative 1, which is x to the 2. But if you want to think of it as just kind of canceling one of them from the bottom, that works too. But technically, that's what's going on. Okay, now what? Now we ping pong back and we say, okay, this x to the 2, I'm going to multiply it by x minus 2. And I'm going to subtract it from whatever is up here. Okay. So now, let's see if I can find a, how about light blue? 3, you take x to the 2 times x minus 2. Kind of multiply it down. X to the 2 times x x to the 2 times x minus 2 is x to the 3 minus 2x squared. You always want to have or get back to the same power that you're chipping away at here. Okay. So down below, you're going to write x to the 3 minus 2x squared. And just make sure that you're lining up the appropriate powers. Okay. X to the 3 and x squared. And then I'll do it in red because it's a subtraction. Subtract from above. Now the key is you want to subtract this whole thing. So now you have brackets, right? So you have to transfer that negative inside. And what does this look like? X to the 3 minus x to the 3. Now that's going to go away, and that's how we're going to chip away at this thing. If they don't go away, then something has gone wrong. Okay. So this becomes 0, and then 4x squared minus negative 2x squared is really 4x squared plus 2x squared, which puts me at 6x squared plus 6x squared. And then 5, bring down remaining terms. So this guy comes down and this guy comes down. And I get minus 5x minus 14. No, I'm not going to write the x's anymore. Because we just have to make sure that they're there, but then you don't have to write them. X to the 1 is just x, and x to the 0 is just 1. Okay. Now what? Now we do it all over again. But with this little guy. What color haven't I used? Green. Start over with the new term or the new polynomial. Okay. So now you're working on 6x squared. 6x squared divided by x is 6x. So here, we'll call this the A line. Should use the same. For my B line, because I'm going to use the same step numbers, but now I'm going to have 6x squared divided by x is 6x. So plus 6x. Notice that up above here, you're going to, because you're chipping away one of the x's, you're going to start not at x to the power of 3, but x to the power of 2, and then each of the terms will be represented still. But it's going to be just a little bit smaller. Is the
bottom left there, what did you write there for the
6x squared? Oh, this is a step 2.
Ah.
And my iPad just flickered, which now I'm on high alert. Let me just check the Zoom. Everything looks. Pardon? Oh, really? Okay, so maybe it was flickering for real. Thank you. I don't know what to do about that. But okay. My Zoom. I also want to label up here where they came from. Okay. So now we're going to do the same thing. Maybe I'll just push chords in harder. Is that maybe?
shake it.
Yeah. Something like that. Okay. So now we're chipping away at the 6x squared. Now I can get to the 6x squared by taking the 6x and multiplying it by x minus 2. So in the same kind of blue step here, I'm going to have 6x times x minus 2 is 6x squared minus 12x. Which is what I put below 6x squared minus 12x. And again, just making sure that you're lining up with the matching terms, right? The x squared has to go below the x squared and the x has to go below the x. And then we subtract from above. And again, the surefire way to make sure that you're on the right track is to make sure that this goes away. The 6x squared minus 6x squared should be 0, which it is. So that's great. How about negative 5x plus 12x? What is that, 7? Negative 5 plus 12? I gotta make sure. Feeling good about it. I shouldn't say that in case I'm wrong. Negative 5 plus 12. Phew. Plus 7x. And then bring down the remaining terms minus 14. Just gets plopped on. So you don't want to forget about those guys. But there's nothing that we can do to them yet. Okay. Now, start over with the new polynomial, which is 7x minus 14. Now we're going to chip away at the 7x. Let's see here. This is from B. I was trying to not add a page, but I guess I have to. C. Now we do the same thing over again. 7x divided by x makes 7. And so step 2, 7x divided by 7, or 7x divided by x is 7. So I get plus 7. Step 2. Now I take this 7 and multiply it by x minus 2. Oops. 7 times x minus 2 is 7x minus 14. Which is nice. Why? Because that's what I have here, 7x minus 14. Then I subtract that. And I'm left with 7x minus 7x, phew. Negative 14 plus 14. Well, I'm gonna go with plus 0. So then I'm done. So from C, we end up here. And this is from step C. So what does that mean? Means I can rewrite x to the 3 plus 4x squared minus 5x minus 14 as x minus 2 times x squared plus 6x plus 7, which, ta-da, is a quadratic, which we know how to deal with. So therefore, and maybe I should start down here, x to the 3, now I wish I could remember, plus, let me just snag it. I'm gonna cheat, copy. I'll remove the x's there. Divided by x minus 2 is x squared plus 6x plus 7. That's cool. Because this is a quadratic. What if you wanted to factor this quadratic? We could find the roots. Right? And so we can rewrite, we can factor a quadratic using the quadratic formula. What we're going to do is we're going to find where this thing is 0, x squared plus 6x plus 7. Right? And so we have x is negative b plus minus the square root of b squared minus 4ac divided by 2a. In this case, a is 1. B is 6 and C is 7. So I have negative 6 plus minus, I really hope this one works out, 6 squared minus 4 times 1 times 7 divided by 2 times 1. 6 squared minus 4 times 7 is 8. Okay, not beautiful, I guess. Shoot, that's okay. Negative 6 plus minus the square root of 8 divided by 2. when I use my calculator to do the root of 8, it simplifies to 2 root 2, which I will grab because then I can cancel the 2, right? I can rewrite -6 as 2 times -3. So then this can cancel. And this becomes -3.
Is it okay to leave that root 8 for final answer?
Yes. But it gets a little bit tricky because this was a bad example. I shouldn't have gone this far with it. We're going to stick with it, but usually it's a little bit nicer, the quadratic. We can pretend this was a 9 instead, right? The root of 9 is 3. But we'll stick with it. It is just a number, so it's not the end of the world. But we get -3 plus minus the root of 2. Which means -3 plus the root of 2 is a root, and -3 minus the root of 2 is a root. You'll see why. Actually, these two values of x make, find another page, make x squared plus 6x plus 7 equal to 0. What I was hoping is that it would be two nice numbers, but they're not. So we're just going to leave it at that. And I'll grab some nice numbers instead. But before we do that, we've got more practice. But the factor and remainder theorems. So when you divide a polynomial p of x by some divisor polynomial d of x is the notation we'll use, we get a quotient polynomial q of x. And it is possible to end up with some remainder r of x, which means that we can rewrite p of x as d of x times q of x plus r of x. So in the previous example, in our example, p of x was x to the 3, now I can't remember, but oops, I might have it in my paste, yeah, score. We divided by x minus 2, and we found our quotient was x squared plus 6x plus 7. And we had no remainder, so it's 0. I'll make a note here while I'm thinking of it. On your assignment, it's going to say use synthetic long division, I think, but I'm only teaching you long division. And so if you're interested in synthetic, it's supposed to be easier, but I don't want to show you two kind of difficult ways to do the same thing. So I'd rather just focus on one difficult way to do things. And then if you're interested, you can learn synthetic long division if you want. It's just a little bit shorter. You're welcome to use it on the test if you prefer it. If you kind of read through it and you find that, okay, this makes more sense to me, you're welcome to use that. In the assignments, it'll ask you to enter what each of these terms were. So it doesn't matter how you got there, right? As long as you're able to do the division and find it. So on the assignments, or on the assignment, it might say use synthetic division. We will only cover long division. But you are welcome to use any method, or not any method, either method. So I'm sure there's some great videos on polynomial synthetic division, but we're just going to use long division. All right. Because it's pretty satisfying when you get there. Okay. Oops. Just had to make sure the factor theorem was on there too. Okay, so the remainder theorem. If P of X is a polynomial of degree 1 or greater, meaning it has some X, okay, and C is a real number, then when P of X is divided by X minus C, the remainder is P evaluated at C. That's just kind of a fun thing. It's not something that I expect you to memorize. It's kind of a relic on our learning outcomes. This is one of your learning outcomes, that you have to know the factor and remainder theorem. I think that's pretty stupid. So, but I have to talk about it. So this is me talking about it. So what does this look like? Well, from our example, in our example, P of X was X to the 3 plus 4x squared minus 5x minus 14. When we divided by d of x, x minus 2, right, that's the same thing as if you map it to x minus c, then c must be 2. We already did the work, so we know that the remainder is 0, right? But so we know r of x is equal to 0. But what's another way that we could do it? So if P of X is a polynomial and C is a real number, well, 2 is a real number, then when P of X is divided by X minus C, the remainder is P evaluated at C. Okay. So by the remainder theorem, P of C, which is P evaluated at 2, must be 0. We can confirm. P of 2 is 2 to the power of 3, plus 4 times 2 squared minus 5 times 2 minus 14. 2 to the power of 3. I'll just do it here. 4 times 4 is usually 16. minus 10 minus 14. 8 plus 16 minus 10 minus 14. Phew. Only time that I would think that this would be kind of useful is if I've done a polynomial long division and I find a remainder, then maybe if I'm able to check it by using the remainder theorem to make sure that it is in fact the remainder that I'm looking for, right, then I can feel more confident in my division. Okay. So we can use this. We can use the remainder theorem to check the remainder we found using long division, or synthetic if you prefer. To check our work. So that's nice. Evaluate at C. This only works though if you're dividing by x minus c, right? Which will be the case most of the time for us, but right, it only works. So note the remainder theorem only applies when we divide by x minus c. We can divide by other things, but only if it has the shape of x minus c. So, how about the factor theorem? If p of x is a non-zero polynomial, fine, then the real number c is a zero of p of x if and only if x minus c is a factor of p of x. That is pretty obvious. So if p of x is a polynomial, okay, then the real number c is a zero. So here we were able to write out having this original function in my paste is really paying off. Now I'm going to bump these down. We're just going to do more examples later. Okay. Wait. We had d of x is x minus 2. And we found q of x was x squared plus 6x plus 7. This means we can write x to the 3 plus 4x squared minus 5x minus 14 is the same as x minus 2 times x squared plus 6x plus 7. So what this is saying is that c is going to be a 0 or a root, right? So C is a 0 or C is a 0 or a root if C makes the overall function equal to 0. If C let's do this. If x equals C makes P of x equal to 0. That's what it means to be a root or a 0. So let's talk ourselves into that. C is a 0 if x minus C is a factor of P of x, which it is. We found no remainder. And so here, x minus 2 is a factor. Which means that, okay, by this theorem, C equals 2. If I let x equal to 2, let's use a different color. Let x equal 2, then I get in P of x, I guess I should have used a different, that's okay, whatever. Let x equal 2 in P of x, then I get P of 2. You can use either one here, but we have this factored way, and so that one is going to be more obvious. And so here, we already did P of 2 by the remainder theorem, right? And we found that it was 0, so that makes sense. And so now let's use this factored version is 0 minus, or sorry, not 0, 2 minus 2. 2 minus 2 times x squared plus 6x plus 7. If I'm able to make one of the factors 0, then it doesn't matter what I multiply by 0, it's going to be 0. And so this is going to be equal to 0. Therefore, P of 2 overall is going to be 0. It doesn't matter what I multiply by 0, it's always just going to be 0. So that's what the factor theorem means, is that, okay, if you're able to factor out an x minus c, then you know that at c, if you let x be c, then you have c minus c, and the overall function is 0, right? And so that's what makes it a 0. Okay. Any questions before we do an example? Another example. And I'm going to bump these guys down. We're going to use long division to divide 5x to the 3 minus 2x squared plus 1. What's the first thing that you need to do? You need to fill out all the values of x by x minus 3. So first things first. I wish I could remember the colors I used. How about I copy pasta here? And then I'll try. What? For this one, we'll work together and then can try that. I'll give you some time to work through the next one on your own. This one, 6. These are going to change. Neat. Yeah. So giving ourselves a space above. I want to do x minus 3 into 5x to the 3 minus 2x squared. But then I need an x in there because otherwise it skips straight to plus 1. So plus 0x plus 1. Just filling in 0 times x. You don't have to write as 0, right? But it is technically what's going on up here, right? We're missing that x. So that's going to be really important because otherwise you'll be subtracting, your subtraction will be kind of off. Okay. All right. So that's good. Now I have x to the 3, x to the 2, x to the 1, x to the 0. Cool. All right. First thing, 5x to the 3 divided by x. And pasted weird. 5x to the 3 divided by x is 5x squared. Just canceling one of the x's. 5x squared. Maybe I'll do my then I take my 5x squared and I multiply it by x minus 3. 5x squared times x minus 3 is 5x to the 3, which is what you need, right, in order to eliminate that 5x to the 3. So that's good, a good start. And then minus 15x squared. So down here, I get 5x to the 3 minus 15x squared. Hopefully that's what I wanted. Guess we'll find out. Now I'm going to subtract this from above. Five x to the 3 minus 5x to the 3 is 0, which is good. That's what we're going for. Negative 2x squared plus 15x squared. I get 13x squared. Then I'm going to bring down these guys, plus 0x plus 1. And then we're going to start over with this new polynomial, 13x squared plus 0x plus 1. $13x squared divided by x you don't have to write it out, is 13x. I'll do A, B. Then for 3, I have 13x times x minus 3, which is 13x squared. 13 times 3 minus 39x. Okay. So then I have 13x squared minus 39x that I need to subtract. 13x squared minus 13x squared goes to 0, so that's nice. 0x minus negative 39 is really plus 39x. And then I bring down my plus 1. And now I can do my last term. Oh, doesn't look like a 1. There we go. $39x divided by x is 39. So plus 39. And then 39 times x minus 3 . 39x minus 39 times 3, oops, it's 117. Which 39x minus 117, subtract that. 39x minus 39x makes 0. 1 plus negative 117 is plus 118. 1 plus 117. I'm out of x's here. So that means that I have this remainder. Oh, I'll use a different color here. We are out of x's. So the remainder is 118, or r of x is 118. We can use the remainder theorem to confirm. We can use the remainder theorem because we divided by something of the form x minus c. So here, p of x was this. Now you don't have to write the plus 0x, but is x minus 3. So if you map it to x minus c, c is equal to 3. So what we want to do is to confirm that p at 3 is 118. I'm really hoping that this works out for me. So we can confirm that P at 3, which is, or maybe I'll do it generically first. P at C is 118. So P at 3 is 5 times 3 to the 3 minus 2 times 3 squared plus 0 times 3, just for completeness, but you don't have to, plus 1. Okay, 5 times 9 is 45. This doesn't look good, does it? Because 3 to the power of 3 is 27, haha, times 5. 135. That was a close one. Minus 3 squared times 2 is 18 plus 0 plus 1. 135 minus 18 plus 1. Whew. Give myself a happy green check mark. That makes me happy for a couple of reasons. Well, it worked. It was when I was doing 3 to the power of 3 is 9. Well, that was wrong. So that didn't feel good. But also, what does this tell me? This tells me that, okay, it's very likely that the division that I did is correct, right? Because I found the same remainder, and the only way to do that really is by having the correct quotient. So that feels good. Okay. I'm gonna put this one on the next page. I want you to try this one on your own. Give you 5 minutes. I'll pause the video here. Now I'm not going to write out the steps alongside. I think we're ready to just go for it. First thing, make sure that all your x's are represented from x squared, 4x squared plus 3x minus 1 times x to the 0. So that looks good. 3x minus 1. 4x squared divided by x is 4x. 4x times x minus 3 is 4x squared minus 12x. Subtract that. I get 4x squared minus 4x squared is 0. 3x plus 12x puts me at 15x, and then bring down the minus 1. Now I start over. 15x minus 1 divided by x minus 3. 15x divided by x is, 15. Now 15 times x minus 3 is 15x. And 15 times 3, let's see, 45 probably. Minus 45. But subtract those. 15x minus 15x is 0. Phew. And then minus 1 plus 45. So plus 44. Which means I have a remainder of 44. So what do? I have p of x was 4x squared plus 3x minus 1. D of x was x minus 3. Q of x is this quotient that we found, 4x plus 15. And the remainder is 44. I'm writing it out this way because usually that's how you have to answer it in the assignments. We can check our work with the remainder theorem because we have a remainder. And so we can check our work because we divided by x minus 3. Right? And so here, this as x minus c, c is equal to 3. We can check that p at 3 is equal to 44. P at 3 is 4 times 3 squared plus 3 times 3 minus 1. Phew. So then I can feel good about my division. So that's nice. Okay. P of x is going to be d of x times q of x plus r of x still divided by d of x. Because the remainder of 44, it's not just 44, it's a remainder of 44 divided by x minus 3. But I think that's fine. Okay. You guys ready for a sneaky one? Sneaky. Okay, on the 21st. Communications, huh? Okay. That's okay, we can move it. When would you like to do it? That feels like a bit of a stretch.
We're almost getting into December.
I know, December is breathing down my neck.
I think that Tuesday, the following Tuesday.
Okay, so here we are today.
That's on Monday. It's a Tuesday. Oh, it's Tuesday? Oh, that's not that bad. Wait. Oh, yeah. I always think math is on Mondays. Yeah, me too. Wait, it's Monday, Thursday. You know what, I gotta wake up early.
So like I just go you guys are almost no matter what, and I don't really feel like I have to study for communication.
Well, I was gonna say, it communications, you just go in and do it, don't you? But I am happy to bump things around.
Abby said, to see next week of the 26th.
26th, the Tuesday. We can do that. How does the 26th sound? Whoop, I'll do a.
That is the midterms on the 20th and then the 20th.
Oh, sorry. Okay. I'll bring that in here. Uh-oh, now it's thinking. I don't like it when it's thinking. bring this in here. Yeah, I'm like, me or Janice? Is it Janice? Yeah.
Yeah. Well, if I ever get dogs. I'll set up rules on the 30th, so.
We'll switcheroo those. So there's a rule that says you can't have a test worth more than 15% of your grade in the last 5 days of classes.
We just say.
And so we're still safe, but we could still do it on the 28th, but I feel like it's a little bit late. And so how about the 26th? Like we just said, we'll bump it. Then you'll have the whole weekend to worry about it, not have any fun at all. And yeah, really let it ruin your weekend.
Are we getting guilt trip to moving it back to the 21st?
No. No, it's fine.
Yeah.
Is open with that if everybody else is good with it.
Sounds like everyone's on board. So to that, I say, or should I make it quiz?
Test is looking pretty good, but yeah.
Like you had this plan.
Well, there's all these fun stickers that I always forget to use. Ah. But here, it's working out. Okay, so now I'm going to scroll to the top and make that change right away. Tuesday, November 26th. That's fine. We'll just start chapter 5 the week before, and it might be nice to have a buffer day. I hate trig anyways, so. Am I allowed to say that?
Yeah.
I'm allowed to dislike things. I really enjoy polynomial long division though. So. It's definitely on the 26th. And then hopefully now you'll have to put off anyone else who tries to schedule something on the 26th. Or not. It doesn't really matter to me. I'm sticking to the 26th. Are you ready for this doozy? Why is it a doozy? Yeah, we're starting.
Such a big number.
We're starting at a higher degree and a square. Uh-oh. But it's impossible. Step number 1, trust that it is possible.
All right for that.
Do you want time to work through it on your own, or should we just do it together? Time on your own? Here, I'll pause it. Give you 5 minutes to work through it on your own. Keep going. All right. Let's see here. First things first. 5x to the 4, x to the 3, x to the 2. Uh-oh. X to the 1, x to the 0 is there. But we need to rewrite this as 5x to the 4 minus 3x to the 3 plus 2x to the 2 plus 0x to the 1 minus 1 times x to the 0. That would be your first step. But now, I think we're ready. 5x to the 4 minus 3x to the 3 plus 2x squared plus 0x minus 1. Being divided now not by some x minus c, but x squared plus 4, which means the factor and remainder theorem don't apply anymore. That's okay, we can still do it. Okay. 5x to the 4 divided by x squared is 5x squared. 5x squared times x squared is 5x to the 4, but 5x squared times 4 makes 20x squared, which has to go underneath the x squared. Kind of tricky. So when we subtract this, those are the only two being subtracted. The other ones are being brought down. I guess technically minus 0, but that's fine. So I get 0, and then 2x squared minus 20x squared minus 18x squared. The rest of them, I mean, yeah, technically you're subtracting 0. But for me, I just think of them as being brought down. Now, I have my new polynomial negative 3x to the 3 divided by x squared. So this puts me at negative 3x. Negative 3x times x squared is negative 3x to the 3. And then negative 3x times 4. But just remember now it's in just one x. So negative 3x times 4 is minus 12x. Subtract those guys. First one goes away. Negative 3 plus 3 is 0. And then 0 minus negative 12 is plus 12x. And then I have minus 18x squared minus 1. Again, lining up your x's. Which is why it makes such a mess if you don't have a spot for the 0x. Right? Even though it's just 0 times x, but then later there's going to be an x popping up, so that's why you want to make a space for it. Okay. Negative 18x squared divided by x squared is negative 18. Negative 18 times x squared is negative 18x squared. Negative 18 times 4 is minus, sorry, I don't know what happened there. Minus 72. Subtract that. I get 0. And then negative 1 plus 72 is 71 and plus 12x, bringing it down. I can't divide 12x plus 71 by something x squared. Yeah. And so this is now my remainder. Is 12x plus 71. Nice. Okay, a little bit tricky. I kind of want to. Let me see here. Come on. Start rational functions, because then what I can do is I'll post the assignments for all the sections in chapter 3, but you'll have lots of time to do them. So we're going to finish 3.7 next day. But let me just start it, because why not live a little? There isn't, I know you usually print out the notes, but there's like nothing in it. It's just more examples. Okay. So what we've been working with is called a rational function. So a rational function is anything where you have, well, let's review some terminology. Your numerator is p of x. Now it goes on top because it's numero uno in my, that's how I remember it. And then this is the denominator. Oops. So a rational function is a fraction where each of these are potentially polynomials, right? P of x is polynomial, Q of x can be a polynomial. And so P of x and Q of x can be polynomials, which is what we just saw. So now we have these fractions. And so what we can talk about is, okay, well, first thing, number one thing about fractions is we know we can't divide by 0. Oops, by 0. That's just a fact. Which means that any value that makes Q of x 0 is not in the domain. Which means any value of x that makes Q of x equal to 0 is not in the domain. Some toolkit functions that we haven't really talked about besides that first day when we talked about all the toolkit functions, but now we're going to talk about the reciprocal function. 1 over x. One is technically a polynomial, although it's extremely boring polynomial, right? It'd be 1 times x to the power of 0. Monomial, I guess. X is also an extremely boring polynomial, right? 1 times x to the power of 1 plus 0 times x to the power of 0, right? But these are technically rational functions, just very boring ones, right? And so we can write it as a fraction. So this is the reciprocal function. We know we cannot divide by x, right? X equals 0. Sorry, we can divide by x, but we can't divide by 0. So here we know that x cannot be 0 in the domain. What that ends up looking like in our graph is, it looks like this. It becomes a vertical, what's called a vertical asymptote. Asymptote at x equals 0. Because it can't be x equals 0. So what it does is it has this kind of behavior around x equals 0. And let's see here. I need more room here. I'm gonna add a page and bump these guys all down. So what we're going to say is that, okay, any function with 1 over x, so 1 over x to the 1, 1 over x to the 3, so any odd reciprocal function is going to have this shape. And so in general, the shape, as opposed to x squared, right, 1 over x squared, so the reciprocal squared function, I guess I can write that down. Reciprocal squared function also has a vertical asymptote at x equals 0 because x squared can't be 0, and the only way that I can make x squared equal to 0 is if x is 0. And so here, x can't be 0 in the domain. But in this case, it looks like this. So it also has a vertical asymptote at x equals 0. So that means it's approaching, so in both these scenarios, these lines are approaching that vertical line at x equals 0, but it's never actually going to touch it. Right? We can get very, very, very close. Okay. And so the notation we use to describe this behavior is if f of x is 1 over x, then we have an asymptote, we have a vertical asymptote at x equals 0, right here. But what we're going to say is we're going to be approaching x equals 0 from the left, and we're also going to be approaching x equals 0 from the right. Okay. And so as x goes to 0 from the left, we use a little from the negative side. Okay. So here, you're going to read this as x goes to 0 from the left or negative side. What happens to f of x? F of x, this function, as I'm approaching from the negative side of 0, right, but I'm still approaching 0, then this function is going to be going towards negative infinity, right? It's heading down. F of x is going to negative infinity. So here, as I'm approaching as x goes to 0 from the left, it's heading down. Same thing, as x goes to 0 from the right, I'm heading up towards positive infinity. And as x goes to 0 from the right, f of x is going to positive infinity. That describes the overall behavior, just like we had for polynomials, right? We know that, okay, if I have an even power, I know that it's going to look like the end behavior is going to look like a parabola, right? If I have an odd power, then I know the end behavior will behave like x to the power of 3, right? Then if I flip it, it flips it around, right? And we're going to have the same scenario here. But the end behavior of this thing is a little bit different because of the asymptote. Now, if I talk about 1 over x squared, right, I can still summarize the end behavior, and I can say as x approaches 0 from the left, then f of x is going to positive infinity. And same thing, as x approaches 0 from the right, it's also going to positive infinity. And that's going to describe the behavior around this vertical asymptote. And so vertical asymptotes are the reason that we spend so much time talking about domain of a function, right? So we know what to extract because they're not, they're going to make vertical asymptotes later on. And so maybe I'll do a line here. If f of x is 1 over x squared, then as x goes to 0 from the left, f of x is going to positive infinity. And as x goes to 0 from the right, f of x is going to positive infinity again. Oops. You can try these before Tuesday, try them on your own. If you have to find the vertical asymptotes of this thing, you need to make sure that the values where this is equal to 0 are out of your domain, right? Making them vertical asymptotes, right? You can use the quadratic formula, right? Because it is a quadratic, so that's nice. And then you can figure out the values of x that make that 0 and then pull them out of your domain, and they are the vertical asymptotes. This one's nice and factored. And here's another one with the quadratic. So getting really used to using that quadratic formula is going to pay off. And in terms of the test question, we will do those next day, but I do want to kind of there's a lot more in the section if you're reading the textbook. So for us, all I'm expecting you to be able to do is, if I give you some rational function like this, p of x over q of x, so just like these ones up here, something like that, I need you to be able to find the vertical asymptotes, probably using the quadratic formula, right? Or if it's factored, that's nice. Next day, we'll talk about holes. If there are holes in the graph, if there are, where are they? And is there a horizontal asymptote? If so, what is it? And here's what it is. So now you have something to look forward to all weekend. So we'll do that on Tuesday. If you have any questions, let me know. Otherwise, I'll see you then.